Number 12 on page 3, we are being asked to do f plus g of x. So remember, this notation just is asking us to add together the f function and the g function. So let's just write that in polynomial form with the plus in between them. 2x plus 1 over x plus 5 and x minus 5. Okay? And they want us to add x minus 4, which is the g of x function, over x minus 5 and x plus 3. Okay? And so if I'm looking at this problem now, they're really asking us to add together two fractions, and in order to add together two fractions, they must have common denominators. So I'm going to compare the denominators of these functions and say the one on the left has an x plus 5 and an x minus 5. The one on the right has an x plus 3, which is not in this function. So I need to bring in an x plus 3 here. Okay? Which means I also need to bring in an x plus 3 in the numerator. Okay, so I'm going to put parentheses around this function to keep them separated. And when I look at the right-hand function, I'm going to compare again and say this one has 3 factors now. It looks like the one on the right is missing the x plus 5. So I'm going to bring in an x plus 5 and an x plus 5. So again, I'll separate these functions with parentheses. Okay? And so now the denominators match each other. So I'm going to say I can add together the numerators. If I FOIL out and multiply out the top one, it's going to be 2x squared plus, I get 6x and another 1x, that's 7x plus 3, right? And in the other fraction, I get x squared plus 1x, okay, minus 20. And this is all over that common denominator. And I'm just going to put them into one big fraction to save myself having to write out this denominator twice. Right, so this is going to be x minus 5 and x plus 3. All 3 of these are a part of my common denominator. So now I just have to combine like terms in the numerator. It looks like I have 3x squared, I have 8x, and I have minus 17. And again, it's all over this common denominator. Don't forget to write the denominator. That is a part of the answer. I can't say that the fraction is complete without that denominator. So I would say this is my final answer. I've added together f plus g by finding common denominators. I simplified it as much as I could. That's my final answer. All right, so if we move on to the next one, problem number 14, they're asking us to transform a point, right? And we're doing to do 2 of them because there's an x-intercept and a y-intercept. So I'm going to come over here, and they're saying, what point does the x-intercept of f of x? So f of x is this graph. That's what they tell us at the top. So the x-intercept is this point right here. So if I count over -1, -2, -3, -4, 0. So we're starting off at the x-intercept at -4, 0. And they want us to use this information for g of x to transform that -4, 0 and come up with a new point. So this is those problems where you see our handy chart here, which says if I'm trying to transform the x coordinate and the y coordinate, I use b and c to transform the x coordinate. I use a and d to transform the y coordinate. So remember, black cats and dogs, that's how we remember that. And then I use multiplication for b, I use addition for c, I use multiplication for a, and I use addition for d. So I'm going to use this table, and I'm going to transform this one. So I have to identify. It looks like I have an a value. I don't have a b value. I have a c value, and I have a d value. So the first thing I'm going to do to start off letter a is I'm going to start off with -4, 0, okay, which remember is an x and a y. And this says that I should add a to the x value, add c to the x value. My c value is 3, so I'm going to add 3 to the x value, and that's going to be, if I say -4 plus 3, I get -1, right? So this is a c transformation only, okay? And then I'm going to do, we'll bring it down here, an a transformation. This says multiply a by the y value. So if I multiply the y value, my y value is 0 on my most recent transformation, and I'm going to multiply -2 times 0. Well, guess what? That doesn't really change anything because 0 times -2 is still 0. So I'm still at -1, 0. And then I need to do a d transformation out here, which says add 4, because that's my d value, add 4 to the y value. So I'm going to end up at the point -1, 4. And I'd say this is the answer to their question. After all 3 of these transformations, on my x-intercept, I end up at -1, 4. And so I can do the same thing with the letter b. The reason that we're doing this one is because it does have a b value, and we have to be careful with that b value, that we put it in its correct form. So let's start off by identifying my y-intercept. My y-intercept in this case is the point 0, 1, 2, 3, 0, 3. Right, so I'm going to start at 0, 3. And I have an a, and there's my d. We have to be careful with b and c because it needs to be in this form, factored form, x plus 4, before I'm allowed to identify c and d. So I'm going to say my b value is 2, my c value is negative 4. Remember that minus sign in the function means that I actually had to plug in a negative 4 before I could get a plus sign in the problem. So now if I start letter b, here it is. Okay, let's use a different color. I'm going to start at the point in 0, 3. Okay. And I'm going to do, since I have all 4 values, I'm going to do 2 transformations at once just to save myself some writing. So this one, it says I'm allowed to do b first and I'm allowed to do a first. So let's do both of those, b and a. So this says multiply the reciprocal of b, so be careful about that. That is different than a, right? Multiply the reciprocal of b by the x value. Well, my b value is 2, so the reciprocal is 1/2. So I'm going to multiply 1/2 times 0, which luckily for us, 1/2 times 0 is still 0. And I'm going to multiply the a value, which is 3, multiply the a value by y. So 3 times my y value would give me 9. Right? And now I'm going to do my other transformations, which are c and d. And so this says add c to the x value. So I'm going to add the negative 4 to my x value, which will make 0 plus negative 4. Well, that's negative 4. And then I'm going to, my d value is negative 1. It says add d to the y value. So if I add negative 1 to the 9 that I have here, I'm going to get an 8. So I'm going to say negative 4, comma 8 is my final transformed point. So I'm going to say this point 0, comma 3 would end up after this particular transformation over at negative 4, comma 8. All right, so next problem, problem 15. They're asking which one of these is not true about this function, this polynomial function, x cubed plus 5x squared minus 4x minus 20. So if you notice, all of my choices here, B, C, D, and E are all about the zeros of the function. So we need to find the zeros of the function in order to identify if any of these is not true. So I'm going to go through and say, okay, plug in a 0. And if I would want to find out what the zeros are, I need to put this in its factored form. So I'm going to factor this, right? So I'm going to start off by pulling out an x squared. So we'll do a little bit of the work up here to save ourselves some space, okay? So we'll bring it down here. So if I look at my first group, so it's got 4 terms, I'm going to use the grouping method. So I'm going to pull out an x squared. And then it becomes x plus 5. Okay? And in the second group, I'm going to pull out a negative 4, okay, which also leaves behind an x plus 5. Okay, and so let me regroup this. Remember, my outside terms become one group. That's x squared minus 4. And then I have the x plus 5, which was repeating. Okay? And this factors again because x squared minus 4 is a difference of squares. So this is going to be x plus 2, x minus 2, and x plus 5. Equals 0. So I'm going to say, here are my 3 factors, I'm sorry, my 3 zeros, negative 2, positive 2, and negative 5. Okay? So these are 3 zeros. So if you notice, there's one missing, right? Negative 2 is a factor, so that's out. Okay? 2 is a factor, so this is out. Negative 5 is a factor, so this one's out. So it actually looks like, which one is not true? It looks like 5 being a 0 is not true. If we want to confirm that A is not true, I'm sorry, that A is true, this one says, as x approaches infinity, f of x approaches infinity. So that's our end behavior notation. So let's just confirm this. This is an odd degree polynomial, which remember, when our degree is odd, okay, it's always starting out down on the left. Okay, let's fix that. Odd polynomials are down on the left and up on the right. Okay, even would be up and up to start. And because I don't have any negative leading coefficients, this is actually the way our function goes. So let's translate this. Down means as f of x approaches on the left-hand side, this is the negative infinity. So this is the left. Okay, and on the left-hand side, this is claiming that we should be heading down, right? Because it's negative infinity, and that's what we do have here. And then the other one saying as x approaches infinity, which this means on the right-hand side, which that's talking about the second term, we should be heading up, right? So this is actually saying down on the left-hand side go down, on the right-hand side go up, and that is what's happening with our function. So we can actually say this is also true, right? So it leaves us with C. We knew that already, but we wanted to confirm that there wasn't possibility for A, okay? All right, problem number 17. Okay, so I had to chop this one out. They're actually saying, take a look at all of these choices, and they're saying which one of them fits the description that it is a 5th degree polynomial. It has zeros at negative 2 and 3, both of those zeros have a multiplicity of 2, and there's another 0, okay, which has a multiplicity of 1, and a negative leading coefficient. So there's a lot of information going on here. All right, so let's start off with seeing if we can eliminate any of our choices. So let's start off with fifth degree polynomial. Right, fifth degree polynomial means that the ends of my graph should be heading in opposite directions. So either down on the left and up on the right, or potentially the other way around. Right, so let's just write that down. Fifth degree means our choices are either up, down, okay, or down, up. This is we don't know which one yet. We're not going to eliminate either of these, but it's got to be definitely one of these two because it's an odd degree, and I know it's that because they said fifth degree polynomial. So I'm going to take a look at my 4 graphs, and I'm going to say, wait a second, this one right here is going down on the left and down on the right. That is not up, down, or down, up. That one's out. Okay. The other ones, when I check them, this one is down, up. This one is up, down. This one is up, down. Right. So it's one of those. Right. So I was able to eliminate D using degree. So if I take a look all the way at the end, it says negative leading coefficient. So negative leading coefficient means that it's not up, down. That's where we start. But when we make the lead coefficient negative, it switches it. Okay. Oop, actually, we're backwards there. Okay. We're going to get rid of down, up, right? Because it starts at down, up. The negative leading coefficient makes it up, down. So let me take a look at my choices here. This one is a down, up, right? So it's not A. Okay. And my other two are both up, down. So now I have to figure out, using the rest of the information, which one it could possibly be. So I'm going to take a look, and it says it has to have zeros at -2 and 3. Well, let me take a look at both graphs. -2, 3, and 1. Okay, that fits the description. This one also has zeros at -2, 1, and 3. So that really didn't help us. And so the only other information it could potentially tell us which one of these it is having that -2 and 3 each have a multiplicity of 2. And if you remember what multiplicity of 2 means, is that at -2 and at 3, the graph's going to act like a parabola. So if you notice in choice B, at -2, it's acting like a parabola, and then it goes up and it comes straight through 1, and then it acts like a parabola again at 3. So it looks like this is our choice. Because C, it does not act like a parabola. It goes straight through -2, and it goes straight through 3, and it is not allowed. So we're going to say in this case, this one is not showing the multiplicities. It shows all the rest of the stuff. It does show the zeros. It shows the correct end behavior, but it's not showing the multiplicity. So it looks like choice B is our best option. This is the one that uses the complete description that's given to us for problem 17. Okay, problem 18 is very similar to problem 17, but it's asking us to draw the sketch. So they're saying a 6th degree polynomial. Okay, so 6th degree is even. Okay, and even polynomials are either up, up, or down, down. They're traveling in the same direction. Okay, and so we know that up, up is a positive leading coefficient. Down, down is a negative leading coefficient. So we're not going to use down, down. Down, down is for negative lead coefficients. Okay, so we know that our graph needs to be going up and up on both sides of the graph. Right, so they're saying for this polynomial that we're allowed to have zeros at -2, that would be here, and at 3, which is over here. And it says each has a multiplicity of 2. And so what that means is that we need to bounce off of -2, head back up, bounce again at 3, and then go up again, right, to connect to the ends here. So let's try to sketch that. They didn't tell us anything about y-intercepts. We don't know anything about that. So I'm going to get rid of these. We know that they're going to be up, up. We want a better looking sketch. So I know that at -2, okay, it needs to act like a parabola, because that's what multiplicity of 2 means. So I'm going to just draw myself a little bit of a parabola there. And I'm going to draw myself a parabola here as well. Right? I know coming out of the right-hand side of 3, it needs to just head up forever. And I know on the left-hand side of -2, it needs to head up forever. And so I really just need to connect these so that they're going to come together in the middle. So it might just be a straight-up, like, turn, or maybe we'll have a dip in here somewhere. That would be okay as well. So this would be a good sketch. You might also, again, turn in here and turn again, because we're allowed to have up to 5 turns here. I just used 1, 2, 3, 4 turns, but we could have used a 5th if we wanted to. So this would be an okay sketch. This hits at -2, it hits at 3, right, and it has a multiplicity of 2. It's heading up, up, fits all of the descriptions that we need for it to hit. Okay, problem number 19, find the zeros of the function. We've done this already, so I'm going to say this needs to be a 0. Okay, I'm going to factor the first group, and I'm going to say this has a 4 and an x and a squared all in common for the first group. Okay, and then it looks like it leaves behind an x minus 1. And the second group has a 1 in common, and it's going to leave behind an x minus 1. And so if I regroup, I get 4x squared minus 1 and an x minus 1. Okay, and now I can factor this first one again, still equal to 0. The first one is also a difference of squares. So this is 2 times 2 and x times x and 1 times 1. So I'm going to say 2x plus 1 and 2x minus 1. Okay, and then we're going to leave the other factor, x minus 1, alone. Okay, and this is still equal to 0. And I can now factor each of these, or I'm sorry, set each of these equal to 0 and solve. When I solve this one, I get negative 1/2. When I solve the second one, I get positive 1/2. And when I solve the third one, I get 1. So I'm going to say this has 3 zeros at 1, at 1/2, and at negative 1/2. Those are my 3 zeros. Okay, so last problem for us. Okay, that is the last problem for us. Okay, we're going up to this end of the second page front and back. Right, so we'll continue in the third video talking about the third page front and back, starting at problem number 21.